Welcome back. If you've had a chance to watch part one of our intro to SoilOptix, now we're going to dive into part two. As Zach said, I'm Trevor Thornton with Crop Care, and we work in Western Canada, Northwest Ontario. So without further ado, we'll just drive right in here. So now we're going to start looking at the maps, which is really the meat and potatoes of what we're looking at. And this is where the value really starts coming back for the SoilOptix. So this is a list of the current layers that Crop Care offers to its growers and other partners that we have in Western Canada. Macronutrients, all your macronutrients, NPK, S, calcium, magnesium, sodium, salts, micronutrients, boron, copper, iron, manganese, zinc. Your soil properties, looking at your CEC, pH, organic matter, general fertility index, which is kind of a neat summary that we get from the lab that we use. Wetness potential maps based off of that survey data and drainage intensity, certainly the total count. And then we also look at a bunch of different ratios. And talking with some of our partners in Western Canada, there's probably going to be more ratios coming in the future as they're researching some of the value of some of these that they have with with their growers. But looking at, for example, the potassium to magnesium or the calcium to potassium, or more importantly, that we found a tremendous value in is potassium to boron map. But it really helps takes big data to make it small data so that we can turn it into actionable data. I intentionally skipped over this here right at the top, the texture analysis. This is something very unique to SoilOptix. It's one of the only companies and providers that give you a true texture layer. This isn't something that's estimated off of a CEC because this does predict your texture analysis, but we're actually measuring this. So we got physical sand, silt, and clay layers, which is pretty neat because we can use that when we're building any of our VR prescriptions. We've also added some added maps to what we're doing. So we've added a wasted fertilizer map. We can create an optimum boron map for the field, clubroot risk. We've also added a scab risk for the potato guys out there. And then more coming. We're potentially looking at some different maps or different disease maps. So I think just our imagination and time will limit us on where we can take some of the correlations of the nutrients that we see with the SoilOptix. So our clients and strategic partners currently get over 40 maps. We kind of talked about all of these. The wetness potential is basically a water flow map that you put over 3D. But realistically, we can put any map over 3D at the grower's request if he wants to see how his nutrients are laid out over his field. One that we just wanted to show you quickly here was the clubroot risk map, an extra map. This was designed talking with some pretty good agronomists in Alberta who have serious clubroot problems. And their comment was, can you take all of this data that you have and put it together to allow us to use that to maybe smart scout the fields and pick out hot spots. So in this particular field, you can see we've got a spot right in here where we're at 8 to 10 or 8 to 9 risk level map. So they can use this now and smart scout these fields, find these little pockets, and potentially eradicate clubroot from those regions before it spreads and gets all over the field. So this was a tool as a predictive tool to help smart scout the field. So the SoilOptix basically takes the accurate idea of good zones, which is your where in the field, with the site-specific sampling / grid sampling of your what in one complete map. So it basically gives us the best of a EM, Veris zones, and grid samples. So it basically gives us a high-resolution soil map. We're talking 300 plus points of data per acre. We're also going to the field with a blank slate, and we're sampling the variability of that field, not the average. When you look at a zone sample, you get one map. And that one map has to fit your prescriptions. That one map fits your soil samples. You get one map off that field. And as I said in the earlier slide, you get 40 plus maps. Every nutrient, every texture, every property has its own map and its own layer. And sometimes they do follow the same pattern. So I would expect my sand, silt, and clays to follow similar patterns. But then when you look at your phosphorus or maybe your potassium or boron or copper maps, they're going to follow different patterns. These are not just sexy maps to show you something. These numbers actually mean something, so you need to be able to interpret them properly. Obviously, the texture analysis that I mentioned before, and then the RTK elevation mapping with drainage, wetness potential, and where does water flow. So it allows guys to look at tile drainage, surface drainage, or land leveling, as I mentioned in the other session. So we're just going to look at a few map examples. So right here, I'm in the field at this spot, and I'm looking to the east There's a ridge that goes through the field right there, but specifically targeting that spot. So this is an organic matter map in the background. You can see that spot is right here, right where my blue marker is showing. I don't know if we physically drove this spot with the SoilOptix or not, but it impressed me that the SoilOptix did manage to pick that out, that matched that map pretty darn close. When we look at another field here, this is some optics, SoilOptix total count map on the bottom, and then the Verus zones on the top. What impressed me about both systems here is because we are mapping changes in the field, you can see the general patterns are pretty darn close. So we've got a bit of a triangle shape in this corner, and you can see that my blue marker is going to disappear, but you can see that shape here. We've got this area in the southwest corner of the field, kind of very closely correlates with the Verus zone in that same area of the field. So both systems have done a good job mapping the changes. I would be concerned if their Verus map looked totally different than our SoilOptix, but in this case they didn't. But we're going to specifically zone in on a small area of the field. So when we got to this field to look at it, we spent hours in this field because there was a lot of stories this field was telling us. But specifically, we went to a couple of spots. So in the background, again, we've got an organic matter map, and here we are with the SoilOptix, red meaning a lower number. And you can see the potato crop here is not doing very well at all. It's almost finished. There's no more yield potential there. It's done. Walk a little bit further away, and we get into this green spot, and you can see the potatoes in that spot are absolutely thriving. Potatoes, corn are fun crops to work with because they scream what's going on, because just of the way the crop displays maybe subtleties in the soil, where other crops like canola, wheat, barley, etc., are very subtle on what they're telling you in their soil relationships. But the thing of it is both of those spots were in the same zone. They didn't fertilize off the SoilOptix in this field. They chose to fertilize off the zones. But these are only 60 feet away from each other, and vastly different response in the crop. Should the same? Well, absolutely not. Here's a picture of soybeans from a couple of years ago, and I'm up on this spot right here. You can see I'm on a bit of an island, and the soybeans look okay. Notice that we're at 1.9% organic matter and 67% sand, and this is the one that I want you to remember as we look at this next picture. So we went from this spot, backed up a little bit, and we're in this spot. So this is a sand layer in the background, and you can see this potato, or this is a sand spot where we were just standing. And this is where we've moved to. And you can see the correlation of the soybeans here. They're not doing very well. Look at organic matter, actually went up 0.1% here, which is almost, call it the same, but our sand jumped up to 75%. No amount of different nutrition would change this. Moisture could have helped, but we're dealing with textures in the sand. So we also got to realize there's some things that we cannot change and cannot influence when we're being dealt the cards that we're dealing with the way that Mother Nature laid down the sand originally. Here's another field. We're looking at corn, looking from this spot, looking north, and the lower organic matter again in the background. And you can see the corn's not doing too well. Turn around and look south, and you can see the corn's thriving. Better organic matter, holding more moisture. The irrigation pass hasn't made it around this field yet, so the corn in the end turned out okay. But this was just that transition where it just didn't quite get to that spot yet, but a strong correlation to that organic matter and what we're seeing in the crops. Here we have a field of wheat, and this is actually the red and orange area. Well, the map is, here's another field of wheat. Looking at the map, this is actually a potassium map that we have in the background. So your reds and oranges are lower potassium, your greens would be higher potassium. And looking down at the wheat in that spot, you can see the wheat's not thriving. It's not doing very well. We go to the back corner of the field, and you can see now that the wheat is looking fantastic. The grower was supposed to go out and touch up the potassium in those areas, but forgot to. So we took him some samples and put them back in the shop. Now, these aren't the worst of the worst because we didn't want to beat them over the head too much. But you can see the plants, they're not thriving. They're further behind. We're starting to lose bottom leaves, a little more disease in them. The yield here isn't going to be very good, and a simple application of potassium would have fixed that, no problem. So we can look at the different nutrient interactions and what's causing what we see in the fields. We use multi-layered formulas. So for an example, when we're looking at nitrogen, we're looking at potentially organic matter. nitrates, general fertility index, cation exchange capacity, wetness potential, texture, K to Mg ratio to kick out our nitrogen formula in the end. We can variable rate anything, any product of NPKS, K-Mag, lime, gypsum, biosol, VR seeding, looking at texture, wetness potential, CEC, organic matter, pH, salts and sodium potentially, and then better information if a fellow is farming with irrigation. So we can do variable rate irrigation and or fertigation, or certainly help with water management. We've actually done some variable planning of tile drainage and suggested to the grower, this area, put your tile tighter, in this area, wind it up. In this other area of the field, you don't really need any tile at all. We also look at our sand, silt, and clay, and that's very unique to the SoilOptix system. And we've had growers say, so what? That doesn't mean anything to me. So we've put together the texture analysis now. So we've got a 72% sand, 20% silt, and an 8% clay on that field. And that puts them right in on a sandy loam. And the growers understand their fields when we put it in these terms. But a sand, silt, and clay, to a lot of growers, doesn't necessarily dial it in for them. And why would we want to know the texture? Well, water moves. Is it moving to a sand, or is it moving to a clay? Using it for moisture probe locations. We're actually involved with Ag Canada in Manitoba here a few years ago, installing moisture probes in an irrigated potato field. And instead of them putting in 8 random probes, they put in 5 site-specific probes. And out of the 4 years of that trial, it was the best results they had. So again, if you know what you're starting with, it's a lot easier to get good data out of the fields. And then we look at the wetness potential and the drainage intensity. So the areas that are red are the water shedding areas. The areas that are green are the areas where the water is going to sit a little bit longer. And these blue lines are where the water is going to flow if we have a heavy rainfall. So we had an advisor in Alberta who used to drive all of those low areas, because in their heavier rainfall area, these areas, if we applied the same amount of nitrogen, would lodge really bad. So we have that. So we had these that we used in our formulas as an override to back the nitrogen off in those areas. But when we got the SoilOptix data with the high value of our RTK survey grade, we built that into the formula. So we're able to duplicate what we did with those overrides, but it also picked out more areas of the field because he wasn't able to map them all. But also gave us the inverse. We're now on those same areas. We're also lower in potassium, so we're boosting the potassium to help the plants stand better in those areas as we're trying to manage our production potential in the field. With that, that's everything to show you on a brief introduction to SoilOptix. If you have any questions about anything, don't hesitate to reach out to myself or the folks at SoilOptix, and stay tuned for other episodes of our Tech Talks.